Okay, so in this video, I'm going to show you how to set this up. Again, we have multiple knowns. So we have 2.5 grams of H2, and we have another known of 21 grams of O2. Our unknown will be moles of H2O. So if we look at one known, we're starting with grams. That would be gram A. We're going to have to go to mole A, and then we're going to switch. So this is our A, and this is our B. And we're just going to stop here at mole B because that's what it's looking for. Okay, so I'm just going to look at this first one here, and I'm going to move pretty fast. So we start with our known, and we set it up. Well, if I have grams of H2 here, grams of H2 has to go here, and the step we're looking for is the molar mass of it. Well, hydrogen has a molar mass of 1.01, but there's two of them, so it'd be 2.02 and 1 mole of H2. This should look familiar from before. But now we're here. Ooh, hello. How about you see it? So we started with our known 2.5 grams of H2. And then I noticed that grams of H2 is here, so I needed to put it here. And we're in that molar mass step. So I'm going to find the molar mass of H2, and it's 2.02, and then 1 mole. But I need to get to moles of H2O, which is B. So I need to go through this step, which is going to be the mole ratio of the balanced equation. So our relationship is from H2 to H2O. Now I need it to match diagonally, so this is actually flipped, right? So I'm going to put the 2 moles of H2 on bottom, and 2 moles of H2O on top. Okay, I'm going to leave this here. I'm not going to get an answer yet just because of time. And I'm going to take my second known, 21 grams of O2. I'm in grams of O2. This becomes my new A. I need to get to mole A, so I'm going to use the molar mass for O2 off the periodic table. That's 32 grams of O2 and 1 mole of O2. Okay, so now I'm here, and I need to get here using the balanced equation. Your unknown should be the same both times, but this time your ratio is 1 to 2. So 1 mole of O2 would go on bottom because there's not a coefficient here, so we get to assume it is 1. And then 2 moles of H2O go on top. Okay, so then we can pick up a calculator and we can solve this. I'm going to solve the top, 2.5 times 1 times 2 divided by 2.02 divided by 2 gives me 1.24 moles of H2O. Let me clear that and do this one. 21 times 2 divided by 32 gives me 1.31 moles of H2. Remember, the smaller answer is actually the answer we want. So this is our theoretical yield, and that would be your answer for this problem. This would be your limiting because it made your theoretical. This would be your excess because it made the number that was bigger, and that's extra information.